I'm excited to be here. We came a long way. I'm from Austin, Texas at the Texas Advanced Computing Center, part of the iPlant project, which is that logo. And thank you to the organizers for accepting a talk that has the word beer in it. One reviewer actually asked me if there would be beer in the talk, but they did schedule me for like 11 a.m., so I think that they wanted me to really talk about science. So we'll do it. Please tweet. I'm at John Fonner. And yeah, let me first say that Docker has been so prevalent. It's been hilarious. You're all probably wanting at least one talk that has no Docker in it, but it's not going to be this one. But I will first, let me talk a little bit about iPlant. So iPlant is a cyber infrastructure project that started 7 years and change ago, and it was on this Star Trekian 5-year mission to boldly address the grand challenges in the plant biology world. Of securing the food supply in the face of climate change and things like this. It was really charged with, at the time, tackling problems where there were no resources to be able to do these types of things. And so it's been a collaboration between Arizona, led by Arizona and the Texas Advanced Computing Center where I am in Cold Spring Harbor, though there are many collaborators across the various institutions in the U.S. and beyond. And so build cyber infrastructure they did. There's this is kind of the 3-tier traditional layer cake. iPlant is built on the back of the cyber infrastructure. So on this lowest level, we have really powerful storage facilities that are located, they're federated, so they're located some at Arizona, some at TAC, with the iPlant UK project, which was announced not that long ago. We are hopping the Atlantic, and we'll have resources, or they will have resources to serve the European community as well, that's taking advantage of some of the same technologies. High-performance computers as well is another big thing in cloud computing systems. There's the Atmosphere cloud compute system, and then high-performance computers, we've sort of structured things to always be able to use whatever the latest supercomputing technology is. So we run a lot of jobs on Lone Star and Stampede currently. Lone Star is about to be replaced, and that is no problem because of the infrastructure that ties the top-level services to the bottom-level resources. So in the middle, and this is part of the pipeworks that most people don't see, are a lot of API level services, and I'm going to talk a little bit more about that on the next slide. And these have really, this started as a project within iPlant called Foundational API. It's grown to this project that really stands on its own and is serving many communities now. And at the top, this is probably what iPlant is most known for. There's these GUIs, essentially, graphical user interfaces that let people tap into the underlying resources. So Atmosphere is sort of the cloud system that iPlant has. The discovery environment is I'll show a picture of it in a minute, but it's just a web-based tool that lets you access all the apps and all the data and stuff that's down below. DNA Subway is a really cool educational tool that's leveraged to teach high schoolers and undergrads all about pipelines and sequencing, and has had some really cool success. BOSC does image processing. There are probably a dozen different websites that are powered by iPlant serving various communities where they are providing their own web page and then taking advantage of the underlying infrastructure. And then there's some things that are in the works that are coming. I'll mention Data Commons sort of at the end of the talk as something that's coming. So this is an image of the discovery environment with all the windows closed, so it's just really clean. But the discovery environment does 3 things. It has a centralized data repository, which is really valuable. This is one of the things that iPlant has done really well, is have a space where people can go. They can upload data once. It's now on fat pipes on the internet. You can move it around different places. It's really easy to share in a granular way with other users. It's also easy to just add a public link so where people can download it. And that's been a really fantastic resource and one that I've appreciated as well. There's an app catalog. I think currently there's 400 apps and change in there. Some of them run on the high-performance computing systems. Some run on a little dedicated Condor cluster that's at Arizona. And for everything that you do, once either data or jobs are running within the discovery environment or really anywhere in the iPlant, everything is kept. And so you have this nice history in this analysis area where you can go back and look at everything you did. You can rerun it. You can rerun it with different parameters. You can share it, et cetera, et cetera. Atmosphere, just to mention, is really a cloud for life sciences. It's pretty similar to Amazon It's free up to a certain quota. It's actually kind of like Amazon in that way too, right? The only difference is if you need more time, instead of pulling out your credit card, you just send us an email and say, hey, I'm doing this type of science, and they say yes, carry on. They give you more resources. So you can have instances up to 128 gigabytes of RAM and 16 cores. There are a whole bunch of VM images that are out there for all the sort of common needs. You can actually customize yours if you want and then share it. This has been really common for teaching classes, so professors can throw up an image and they'll know that everyone can pull down and have the same thing. And it's also works well for a lot of the interstitial tasks in a pipeline, right, where there's no app out there that'll do what I need to do. No worries, spool this up. It's attached to the same data store. It's physically located with the data so that you can do the type of work that you want in a customized way. So let me transition to sort of this second piece of technology. So there's iPlant and Agave that I'll kind of treat separately, though it's part of iPlant. It grew out of iPlant. It's a sort of a science as a service platform is kind of how it's branded. And it is middleware. You can, and I'll talk more about API on the next one, but essentially this creates a really clean interface between underlying physical resources and then a top layer, a web layer where you can expose that. Or if you want to use, treat it like an API at the command line or through Python or some other software, then you can as well. There's support for all that. So some people should be asking what is an API. It's been casually thrown around for the last couple days, but it's actually an application programming interface. And if you imagine that end users are sitting at their desk doing some work on the web, the browser and the client side is really good at sending HTTP, right, protocol messages back and forth. And there's a lot of support in JavaScript and other languages for these JSON objects, which is sort of the message formatting for how things are being communicated back and forth. You can contrast this to the way that a lot of really powerful clusters run and advanced computing centers run. You have really fancy file systems like iRods, fast transfer protocols like GridFTP. Things are using SSH to log in or SFTP. Amazon S3 has some of its own protocols, Azure, on and on. There is a total disconnect and non-overlap between the most common protocols that you see when you're actually doing science at the command line and the ones that you're using when you're on the web. And so the question is, how do we link these up? And how do we take the bleeding edge of software that is running on these supercomputing systems and make them accessible to the web? And of course, in this case, the API is the answer. And on the front side, it will speak JSON and HTTP to the web. And on the back side, it will speak these other protocols. So the nice thing about Agave is it handles a lot of the things that are major snags in doing web development, especially web development against stuff you don't control, like supercomputing centers. So it'll take care of authentication. It'll take care of registering systems. So as systems change, you can just register the new ones. It's aware of all sorts of schedulers and things like that. So you just say, hey, this is SGE. Here's the key that you need to log in and the credentials, and you're good to go. This is also inclusive of data systems. Once you have some systems in there, you can tell it about software. This can either be software that you package up. If there's Docker support, Docker is supported. If not, Agave has sort of this innate packaging capability where you just put all the assets in a directory, and whenever you share it publicly, it will tarball it up. It'll do a checksum on it, and anytime someone wants to run it, it'll go check that it's still not corrupt and copy it over to the system, unpackage it, and run it for you. So it's nice and modular. Jobs are all tracked. Files are all tracked once they're inside the system. And metadata is kept about these. So you can actually add your own metadata, and then a lot of metadata from provenance information is there from the start. Notifications are another nice thing that'll pass back. So if you can say, hey, when this job is done, let me know, and then kick off something else that'll do it. And so what we have is a lot of people that are either adding onto the front side. No one goes, yay, I want to extend your API, because that's sort of the hard part of doing the development. But there are a lot of people that are saying, hey, the resources are great. I have a new web front end that I want to expose. There's even a group out of Washington State University where it's just a lab. They have a cluster of like 4 nodes, and they added it on the back, and then they expose it to the DE. So they're extending the back and making it available to their lab through the front end. And so kind of the last step is Docker, and finally I'm to that point. And sort of the typical practice, right, has been that bioinformaticians or biologists have some idea. This gets expressed somehow in code. Python is typically the favorite. And then if they're doing the right thing, they'll post it up to GitHub. This is all fantastic practice. GitHub provides version control on a lot of good things. I would propose that sort of the next phase of how we want to establish best practices is to add in Docker. Docker Hub is a public repository for hosting software. You can actually connect it to your GitHub repository. Half the crowd is like, yep, done it all the time. The other half is like, cool. It takes about 10 minutes. It's really not bad. And what it will do is every time you push a commit to GitHub, and you can sort of set it how you want, it could be versioned or whatever, GitHub will let Docker know, and then Docker will go and kick off a build on your behalf and create a Docker image for you. This is then accessible, and you can just type Docker run, John Fonner / my code. It will pull down the latest version and go run it for you. So this is actually a publication mechanism of code that has all the dependencies that are inside there. For most software that's running Python, it probably takes a file of about 10 lines to do this very cleanly. So the barrier to adoption is really low. And if you want to get fancy and you have some test cases, if you know how to use nose and you're starting to do the right thing, as we heard Hilmar talk about, then Travis CI is a really popular way. You just add a YAML file inside of your GitHub repo. You can connect up the same way. Every time you push a commit, it'll actually go run your test suite against the new code and tell you if it passes or not. So this takes us kind of from the scenario where we have a mess of code that may or may not run to something that we have a fair amount of confidence that will run and is packaged in a reproducible way. All right, so those are sort of the ingredients, and some people are probably going, all right, what's your point? Other people are liking this and saying, yes, this is exactly what we're looking for. So sort of the way that I would connect it together, and one of the approaches for reproducibility that we have is sort of tethering these. So use GitHub and use what you know alongside Docker. This is open source, which in open science, which is very important. Docker actually only gives you one private repo. You can have as many open ones as you want, but so they do a good job of even encouraging open science, which I love. There's version control. This is an app distribution mechanism so that other people can get your code. Love it. The other side of this, though, is that there's a fair amount of convention, and this is really where the burden is on our shoulders. And just like Hilmar was talking about this morning, that there's a lot of training that needs to go into this for best practices. We need to make sure that our code runs the way we want it to. There are some, like entry point is one of the variables inside of a Docker image. If everyone's setting this differently, it'll be a barrier to running code because we don't know how to run the code. It could even make it where it doesn't work, even though it's inside of a Docker image. Having sample data packaged in is important, and having automated testing through something like Travis CI is also really important. Once this piece is in place, it's really easy to pass this on to Agave. There's already an app that Agave has where it will just, you tell it the Docker container and you tell it the command line, and it'll go off and run it for you. And so that gives you job provenance because Agave will keep track of it for you, and platform integration where you can now take your code and give it a GUI on the iPlant infrastructure. And then this also adds, again, I think the major benefits to passing this up through iPlant are both the fine-grained sharing on the app side and then also the data side. So you can execute it where you want. You're sort of bringing the code to the data, and you're able to really set it up where you could publish a paper and say, hey, here's a link to my data, and here's the way that I ran it, and you can, in a few clicks, go do it. All right, so this isn't all the way done, but this is the concept, right? I think that if we look at what the barriers are for adoption, one is that most of the advanced computing resources are just not there yet on supporting Docker. Part of that is that Docker doesn't have full OS support, it has some kernel requirements, but I think it's going to get there. This is one that's going to be solved for us. iPlant Data Commons will also be something that's really nice. It's a way for iPlant to package up all the data and workflows and really make it less of a hassle to go through the steps and more one-click. iPlant's workflow support is pretty lacking at the moment, so that is hopefully something that'll be coming. And then really on the community's back is this establishing best practices for how we're going to build Docker files and make sure that we're using them as expected. Slides are available on GitHub. There are too many people to thank to list here. Ryan Dooley is one of the main developers on Agave. Sriram and Edwin are a couple of people in Arizona that are building out a lot of the iPlant infrastructure, but there are many, many more. And with that, I appreciate your time.